Okay, final vectors question in our workshop. Same sort of structure to the question. We're given the diagram with the information also included in word form, and we're asked to find A to B. So here's point A, here's point B. As per usual, we'd like to travel along here, but we can't, so we're going to have to go in this journey instead. This is going against the 2A vector, so that's going to be negative 2A, and this part's travelling with the vector 3B, so that's going to be plus 3B. So a nice simple mark there, minus 2A plus 3B. Now it then moves on to give us some information where it's going to give part of the diagram in ratio form. So it says A to P, so this portion here is 2 parts, and P to B, this portion here, is 3 parts. So I can see 2 parts plus 3 parts is 5 parts overall. So this portion is 2/5, and this portion must be 3/5. They're both portions of this line A to B, which we've just talked about. So this is now 2/5 of minus 2A plus 3B, and this is 3/5 of minus 2A plus 3B, which I'm sure is going to be useful in a minute when we look at the rest of the question. It then asks us to show that line OP, now OP doesn't currently exist as a line in the diagram, so let's draw that in. Point O is here, point P is here. So we're trying to talk about a line that's now going to exist going across here. Show that that line is parallel to the vector A plus B. So again, we're going to be talking about gradients, and we're going to want to show that the line OP has a gradient of A plus B. So let's get on and do travelling from location O here to location P here. And I think the most obvious and straightforward way is going to be travelling up this side length here from O to A, which is 2A, travelling in the right direction, so that's positive. And then we're going to have this portion of the line vector AB, and we've just discovered that it's 2/5 of this overall vector. So we're going to add on 2/5 of minus 2A plus 3B. So let's expand that out. So we've got the 2A. We've then got 2/5 of minus 2A. So we've got 2/5 times 2. So 2 lots of 2/5. Well, that's 4/5. It's a negative. And we've got then that vector A. So minus 4/5 A. And then we've got 2/5 times 3. So 3 lots of 2/5. Well, that's 6/5. It's positive. And we've got the B. So let's tidy that up now. So what we end up with is 2 whole ones minus 4/5. Well, that's going to leave me 1 1/5 A. And I've got 6/5 of B, but I might change that from a top-heavy fraction into a mixed fraction. So I end up also here with 1 1/5 B. If we now factorise this so we can separate the scalar and we can separate the gradient, 1 1/5 is common to both parts, so that's going to be our scalar, and we end up with A plus B as our gradient, which, let's look back to the original question, asked us to show that it was parallel to the vector A plus B. Well, it has a gradient of A plus B, so it must be parallel to A plus B.